Hello, good day. I hope you are fine. I'm extremely happy today because this is the final video in the Introductory Finance series. Finally, we have come to the end of this course. I'm indeed proud of you. As a first-year student, you have mastered substantial knowledge in finance in one term, from time value of money to basic financial instruments such as stock, bond, and even to more complicated derivatives. Let's give yourself a loud applause. Today, the final topic is about Black-Scholes option pricing model. How to determine the price of an option? Let's learn together. The Black-Scholes model is also known as Black-Scholes model. The Black-Scholes model is a mathematical model for pricing an option contract. The model is widely used in the option market. Three financial economists, Fisher Black, Myron Scholes, and Robert Merton, make a major breakthrough in the pricing of stock options by developing the Black-Scholes model. The initial equation was introduced in Black and Scholes' 1973 paper, The Pricing of Options and Corporate Liabilities, published in the Journal of Political Economy. Merton and Scholes received the Nobel Prize in Economics in 1997. The Nobel Committee acknowledged Black's role in the model as he passed away 2 years before the prize is awarded. The Black-Scholes option pricing model is one of the most celebrated results in modern finance. This option pricing model is a sufficiently important discovery that it was the basis for the Nobel Prize in Economics. The Black-Scholes model has a few key assumptions. First, markets are frictionless. This means there are no taxes or transaction costs. All securities are infinitely divisible. Second, all market participants may borrow and lend at the known and constant riskless rate of interest. Third, stock prices are log-normally distributed with a constant variance for the underlying returns. This means asset prices cannot take a negative value. They are bounded by zero. Fourth, the stock neither pays dividend nor makes any other distributions. And lastly, the option may be exercised only at maturity. Hence, the model is suitable for the pricing of European options. It does not accurately price American options. How different is the Black-Scholes model as compared to the binomial model? Let's compare them. The binomial model is a discrete method for valuing options because it allows security price changes to occur in distinct upward or downward movements. However, prices can also change continuously throughout time. The Black-Scholes formula recognizes a continuum of possible outcomes. The options life is divided into more and more subperiods, with the distribution of possible stock price changes approaches a log-normal distribution. This is usually more realistic than the limited number of outcomes assumed in the binomial model. The Black-Scholes formula is also more accurate and quicker to use than the binomial model. So, why use the binomial model at all? The answer is that there are many circumstances in which you cannot use the Black-Scholes formula, but the binomial model will still give you a good measure of the options value. What is a log-normal distribution? If we divide the options life into many subperiods, we would eventually reach the situation as shown in the figure. This figure is an example of a log-normal distribution, where there is a continuum of possible stock price changes at maturity. The log-normal distribution is often used to summarize the probability of different stock price changes. In the Black-Scholes option pricing model, the option value is a function of 5 variables. What are the 5 variables? Let's take a look at this slide. I'm sure you know what the 5 variables are. We need these 5 variables as input to calculate the option value. Now, we come to the most important section of this video, how to make use of the Black-Scholes option pricing model to calculate the value of a European call option or European put option. This slide gives an overview of the Black-Scholes formula. We shall learn more in the next few slides about the formula. Stay tuned. This slide shows the important symbols used in the Black-Scholes model. 0 stands for time zero or today. C is the fair price of a call option. P is the fair price of a put option. S stands for stock price. X stands for exercise price. R represents the riskless rate of interest. T represents the time to expiry in fractions of a year. Sigma stands for standard deviation, which is a measure of volatility. D1 and D2 is calculated using the 5 variables. ND is a cumulative probability distribution for standard normal wear rates from negative infinity to DI. This slide explains further about the cumulative probability distribution ND. The two figures illustrate the difference between probability density function and cumulative distribution function. From the figure on the right, you can see that the value of the cumulative probability can range from 0 to 1. ND can be derived from a table on cumulative normal probability density function or using the Excel function NORMSDIST. Take note that ND1 and ND2 have certain meanings behind them. ND1 represents the inverse hedge ratio. ND2 is the probability that the option will finish in the money. Let's look into an example. Calculate the value of a call option given the current stock price, exercise price, risk-free rate, time to expiration, and volatility. The details of the calculation are shown step by step in this slide. I hope you will make use of the formula to calculate first and then compare the answer. In this way, you can learn better. We are going to use the same example to calculate the value of a put option. Take note that negative D1 and negative D2 are used. You may use a cumulative normal distribution table to find n negative D1 and n negative D2. The details of the calculation are shown step by step in this slide. Again, I hope you will try on your own first and then refer to the answer. Happy trying! Recall from the earlier slides that the fair price of option depends on 5 factors: stock price, exercise price, time to expiration, risk-free rate, and volatility. All these factors are readily observable except for the variance, which has to be estimated. There are 2 ways of estimating variance. First, we can use historical data on security price movements and calculate variance based on log price relatives. Historical volatility is a useful guide to future volatility. However, changes in volatility occur, especially during turbulent markets. This makes application of the Black-Scholes model difficult. Second, we can use the Black-Scholes equation in reverse to derive the implied volatility. This means if the current call price is known, the Black-Scholes model can be used to calculate the level of volatility implicit in the price, or implied volatility. Finally, we have come to the end of this video. I hope you have learned some knowledge from this video. If you like this video, please click like, share or subscribe to my YouTube channel. Thank you. See you and goodbye.